Let's move to a graphic example of another circuit. We'll need a cylinder, a directional valve, and of course a pump and a reservoir for fluid. Filters too are a necessity with today's highly efficient components. We placed one at the pump inlet and one in the return line from the directional valve. Now by shifting the directional valve back and forth, we can make the cylinder reciprocate, but we haven't provided a place for the oil to go when the cylinder stops at each end of its stroke. So we need a form of pressure control. We'll use a relief valve. Now we'll need something to drive the pump, and that can be anything you select, from an electric motor to a windmill, as long as it can provide the necessary torque and proper drive speed. If this were a circuit for a grinder, we might have a problem. The table would move faster in one direction than the other because of the differential areas in the cylinder. A simple fix would be to use a double-ended cylinder. Then the speeds and forces would be equal in both directions. Now there is another way we could get the same results. It's called a regenerative circuit. For equal speeds and forces, a cylinder with a 2-to-1 area ratio is used. That means with the piston retracted, the fluid in the rod end would be 1/2 of what's needed to extend the cylinder. To make it work, fluid from the rod end, instead of going to tank on the extending stroke, is routed back to the inlet side of the directional valve, and from there into the cap end. This means we will have equal pressure on both sides of the piston, but the greater force on the cap end, because of its larger area, will cause it to extend. Since the fluid displaced from the rod end provides half of the fluid required to extend the cylinder, the pump needs only to supply the other half, and it will take only half as long as it would in a conventional circuit. No, we didn't get something for nothing. Pressure in the rod end resists the forward travel, so what we gained in speed, we lost in force. If it were necessary to regulate the speed of the cylinder, this would be a good application for a bleed-off flow control. The workload is fairly constant, and there's no tendency for it to run away. We would save some energy, too, in that the pump would operate at the workload pressure rather than the